Good morning. In this video, we shall see the basics of the finite volume method. We shall also see why FVM is called a conservative scheme and why we use cell average quantity in the FVM, unlike the finite difference method. The general form of scalar conservative equation can be written as, because we use cells of finite volume and we use integral formulation in FVM, we should integrate it. The integral form of the equation is, the second part can be converted into surface integral using the Gauss divergence theorem. The integral form is, using the method of line approximation, we can convert the partial differential equations into ordinary differential equations. So the equation becomes, if we integrate the first part of the equation, we will get cell average quantity, which is denoted with a bar symbol on the top of U. Similarly, on the right-hand side, we shall convert the integration into the summation of finite surface area. You can observe we have an hat in the second term. This indicates we should calculate the normal vector of the face of the cell in the FVM method. Because we should calculate and store the area and normal vector of the cell faces in FVM, we call the control volumes mesh. But in FDM, we no need to store that information, we call them grids. We shall see why FVM is called conservative discretization in one-dimensional form. For this, we shall consider the following cell of cuboid shape. The length of the cell is h and the area of the faces are a. The cell interface is denoted as I plus 0.5 and I 0.5. N cap is the normal vector of cell faces. Here we assume flow is quasi-one-dimensional, which means flow is coming from left to right and no flow is happening in other directions. The direction vector of n cap at I plus 0.5 is I and the direction vector of n cap at I 0.5 is I because it is pointing towards negative infinity of the x-axis. Substituting the value of n hat in the conservative equation we get. The volume of the cell is the product of the area of the cross-section and the length of the cell. Substituting that in the conservative form, we get. This is the formulation of FVM in 1D. The basic formulation we derived for three-dimensional control volume is. Here you can observe the change in the rate of change in the conservative variable is equal to the summation of fluxes, which is directly related to the integral form of the governing equation. If we replace U with density and F with rho U, we will get the continuity equation. In FVM, we can visually see the rate of change of accumulation of mass in the cell is equal to the summation of inflow and outflow mass flow rate. Other than that, for incompressible flows, we numerically ensure the continuity of fluxes at the cell interface. These are the reasons FVM is called conservative scheme. If you feel the content is informative, please consider like this video and subscribe the channel. Thank you for watching.